In this lesson, we shall focus on mathematics, right? And we shall focus on the comparison test and applications of the comparison test for integrals. And we state again the comparison test. Comparison test for integrals. Be defined on a to infinity and Riemann integrable on AB for every bigger than A. Suppose that zero is less or equal to f of x, less equal to g of x for all x bigger or equal to a, and b, the integral from a to infinity of g of x dx converges, then the integral from a to infinity of f of x dx converges. Converges. But we then say this integral here also converges. Yes, f of x dx also converges. F of x dx also converges. Okay, let's look at the comparison test for integrals. Okay, so we let f and g be defined on the interval from a to infinity in Riemann integrable on a to b for every b bigger than a. Suppose that the f is below g for all x greater or equal to a, and the integral from a to infinity of g of x dx converges. Okay, we are then saying if f is below g and g, its integral converges, then because g is the biggest one, if the biggest one's integral converges, then also the smallest one converges. And also the smallest one does what? The smallest one converges. Then the smallest one converges. Then we proceed as follows. Okay, this is the comparison test. It's sort of the theorem. This is the theorem. It is the theorem. Okay. Now, here we start with We want to prove this one because this is the statement of the theorem. But now we want to prove this. So to prove this, what we then do is we take this particular, the first result, but we take the hypothesis that the 0 is less or equal to f of x, but f of x is less or equal to g. You apply the integral on all the sides. A to n f of x dx. A to n g of x dx. Since 0 is less or equal to f of x gx, g of x increases. Okay. I want to say, but first we look at the fact that f is smaller than g. And you can take the integral both sides on all the sides. Since these particular functions are ordered in this manner, and f is below g, then, and also in the first part, we have that the integral of f of x, dx diverges. Hence, this integral here, this integral, yes, look, we can show the following. If this integral of f diverges, so we're told that an integral of f diverges, then we must show the integral of g diverges. And now we're then saying the integral of f diverges. Hence, the integral of g of x dx diverges. Diverges as n approaches infinity. Thus, we can say then the integral of g of x dx is because here we're saying n to a to l, and then we're saying this one diverges. Right, so in other words, we are recapping on these divergence results, but I'm sure that we shall move faster to make sure that we just go through the theorems. But now, here, what we're then saying effectively is that you have 0 is less equal to f less equal to g. And what we're then having here is the following. You can take the integral both sides, which means that the integral from a to n of f of x dx is less equal to the integral from a to n of g of x dx. Now, if our f is below g, if a to this diverges because the integral of the f diverges as n approaches infinity, hence because f is a smaller one. So if the smaller one diverges, then the bigger one also diverges. If the smaller one diverges, also the bigger one diverges. If the smaller one diverges, also the bigger one diverges. Now let's look at the other case. If the G integral converges, then the F integral also converges. If the bigger one converges, its integral converges, then the integral of the smaller one similarly converges. Let's look at the proof. Now, we can show the following. Now, 0 is less or equal to F, less or equal to G. Okay? We take the integral both sides. F of x dx, g of x dx. Since 0 is less or equal to f of x, less or equal to g of x. Which is g of x. Now at this point, the integral of g of x converges, so the integral of this, therefore, is increasing. It's increasing. Or you can say, this integral here increases. Increases. To its limiting value. As n approaches infinity. Hence, okay, so this one increases to its limiting value as n approaches infinity, but obviously it converges, or it's going to increase to its limiting value, that is a finite number. Hence, the integral from a to infinity, from a to n of f of x dx is increasing. It's increasing. It's increasing and bounded above. And bounded above. Hence, the integral from a to infinity is a convergent integral. It's a convergent integral. It's a convergent integral. So we've proven, therefore, that this is a convergent integral. But we are also stating a very important fact. What is the important fact? If this one is convergent, the integral of f is convergent, but also the function f is below the function g. It therefore would mean that, and this is the case, it therefore means that because of the convergence, by dint of convergence, a to infinity f of x dx is just equal to the a to infinity g of x dx, like so. Exactly like so. So we continue to the next point. We continue to the next point. Right, we continue to the next point. Okay, we'll continue. Okay, let us look at this part here. Okay, now at this point, if you have this particular integral here, and at this point, there are a couple of ways to reason this out. But we actually begin by saying e to the minus x squared is less or equal to that for x bigger or equal to 1. And then we can take the integral both sides of this, but it's from 1. So we're going to integrate from 1 to b, e to the minus x squared, less or equal to, okay, dx, of course. Dx, of course. And then we integrate, because it's from x greater equal to 1. So integrate from 1 to b, e to the minus that dx. Okay, now, so we continue. So now you actually therefore would have to find this particular integral here. 1 to b, e to the minus x squared dx. What is the integral of this? It's minus this 1 to b. Okay, so you find the integral and the integral becomes this. At this point, you take the limit. As 1 approaches b. The limit. And if you have the limit, e minus that. Okay, as b approaches infinity, this is going to be 0, and it's going to be e to the minus 1, which is a finite number. By dint of that, it is clear, therefore, that we can come here and then say the integral from 1 to infinity e to the minus x squared dx, this integral here diverges. This integral here diverges. Okay, it's a recap on the things we spoke about earlier, because we are moving to other things, but yeah, we are recapping, but we are moving a bit faster. Right, so, and obviously, the answer indeed is convergence, and the convergence is brought by the fact that e to the minus 1 is a finite number. Okay, right, good. Good. So we proceed as follows. So now you look at part B. So now this part B is, you can write first is 1 over 2x plus 1 is less or equal to e to the power x, 2x plus 1 for x bigger or equal to 0. For x bigger or equal to 0. So that now at this point, what do? You integrate this, but you integrate from 0. 1 over 2x plus 1 dx. And therefore, 1/2. Um, okay, you integrate this one now. Because you find derivative of this, then it becomes that. And then you, okay, I want us to, by the way, make this finite first, please. In the same way we do the improper. So you put B here. You put B there. Okay, and then obviously if you integrate this now, and then it's going to be 2b plus 1 minus half. Then you substitute 0. 0 plus 1. And therefore, this is the limit. Half by 0 becomes 0. E to the power x divided by 2x plus 1 dx. Okay, the aim is to take the limit both sides at this point. Right, taking the limit both sides. The limit as b approaches infinity. As b approaches infinity, it's going to be the ln of infinity, giving us infinity is less or equal to the limit. Okay, infinity is less or equal to, you can take this one, infinity e to the. We continue. So we're getting that this integral is bigger or equal to infinity. So So this integral here diverges. Okay, you can write here and say hence the integral from 0 to infinity dx diverges. Well, diverges because it is greater or equal to infinity. It is infinite, so or greater than infinity. So it diverges because of that. And then now we're going to look at the next thing. Obviously, this one we are able to understand that it's sort of a recap. It's a recap because we went through this earlier. Okay, the first order differential equations. Let's recap on these quickly. Right, so now we have this one here, which is e to the power negative y sine x. Zero. Cosine squared x. Okay, that's fine. Okay, let's do number 7. Let us do number 7. Let us do number 7. Right, solve the integral equations. Hint, differentiate each equation and solve the resulting equation subject to an appropriate initial condition. So now let us look at this. So in A, you have been given y of x, which is 3 plus 2, ty of t dt. We want to differentiate this one, so we're getting dy of x dx, dx of 3 plus 2, the integral of these y of t dt. Okay, so let us take a look at this particular problem. Take a look at this particular problem. So the integral of this then is the same as what? It's y primed of x. The derivative of the 3 becomes what? 0, 2. If you differentiate this one, you will get this, but you substitute everything into this. So you're going to substitute x, y of x, like this. So you put the x into the place of t. In general, you multiply by the derivative of the x, the limit of integration, because sometimes it's not 1. Okay. Which means y primed of x would be the same as what? So this is 0, and therefore the derivative of this one is exactly 1. 2x y of x. Okay. We get this exactly. We get this exactly. We get this precisely. Now, when you get to this, you then have this y prime is the same as dy dx. 2x y. Okay, is this the approach of the integrating factor? No, this one is called the fundamental theorem of calculus. Fundamental theorem of calculus. This is called the fundamental theorem of calculus. Fundamental theorem of calculus. Fundamental theorem of calculus. Right. The fundamental theorem of calculus is what we use here to differentiate. Okay. It allows us to say when you differentiate this kind of an integral with a variable, you substitute the variable into the place. This is the t, so substitute in the place of t, you put the x. Wherever there is t here, ty of t, then you put x. And then you're going to have also, obviously, this is y of x. This becomes y of x. And then you have this. The y prime is dy dx, is 2xy. You cross multiply and you get dy, which is 2xy dx. Which means it is dy over y equals 2x dx. You get the integral of dy over y equals the integral of 2x dx. Okay, when do we use the fundamental theorem of calculus? We use the fundamental theorem of calculus when we need to solve equations that have integrals in them and want to solve this. Because there's an integral that has been put, but we need to solve this. We always use it when we have a limit of integration that is a variable. You know, and we need to solve this equation, and there's an x here. There's an x there as the limit of integration. So we need to use the fundamental theorem of calculus there. Okay, good. So now we integrate at this point, but if you integrate the dy over y, it becomes the ln of y, which is exactly 2x squared over 2 plus c, which is exactly x squared plus c. And then at this point, what are we supposed to do? You need to use an appropriate initial condition. An appropriate initial condition. Right, because we need to be able to get the value of c. Okay. Okay, now let us pause to look at this. So at this point, t can be 1, but t can also be x. But obviously, we're dealing with the x here. Can y be 1? And then if you put y equals 1, then you'd have 0. Okay. But if you have this, then you are able to see that y is e to the x squared plus c. Like so. And what is this exactly? This would therefore mean the following. The question is, what can you take? What can y be? Y can be a 1, right? So that this is e to the 0. So you need to think about it then and see that if ever you can take y of 0 or y of 1 is 3. Okay, y of 1 is 3 because if you take y of 1 here, then it's going to be from 1 to 1. The integral from 1 to 1 is going to become 0. It's going to become 0, so that now we are just taking the 3 here. So you have the initial condition. Y of 1 is 3. So you have 3, this. Okay, so you need to solve. Ln 3 is 1 plus c minus 1. So which is this? What is e? E is e to the power x squared plus c. What is the c? C is ln 3 minus 1. C is ln 3 minus 1. This is e to the power ln 3. E to the power x squared minus 1. What is e to the ln 3? It is 3e to the power x squared minus 1. And this is the answer. Any questions? So when do we use the fundamental theorem of calculus? We use the fundamental theorem of calculus to solve equations that have limits of integration that are variables. Like that one. So that is something that you need to think about, but you need to understand this very well. You need to understand this very well. So think about it, but this is the answer to the problem. Yes, please.
Can I ask where did you get 3?
This 3.
Yes.
Yeah, because the 3 is, you see now you need to use an appropriate initial condition, but use an appropriate initial condition that did not give you the initial condition like y of 1 equals a number, but you can see that this integral given is from 1 to x. So if you make x 1, wherever there is x, you put 1 here. This integral is going to be from 1 to 1. An integral that is moving from one number to the same number is 0 because there's no change there. Moving from 1 to 1 is 0, and that gives us the initial value. It gives us y at 1 equals 3. And this y is equal to 3 whenever x is 1 because this is going to be from 1 to 1, so that y at 1 equals 3. You get the point? So that is what you have. Right. So we continue. Think about it and make sure you understand these because we are moving on to the next thing. We are moving on to the next thing. We need to practice these questions more. So you need to make sure you understand this problem. But the answer is already there. They wrote y of x equal to 3e to the x squared minus 1, which is that? Okay. Right, so move on to the next one. I can give the next one to you right now to try it in the meantime. But now to try the next one is the same thing exactly. So you just need to differentiate both sides because it's the fundamental theorem of calculus that you're going to use. It is the fundamental theorem of calculus that you're going to use. So now I'm giving you a split second. Okay, some people say a split second to mean the shortest amount of time possible.
Sorry, I'm still confused. To get the 3, so basically you have to substitute the 1.
Yes. To get the 3, substitute 1 in the place of x. Wherever there is x here, you put 1.
Yes. So
And the
these
plus,
are equal.
yes. Okay, let's look at this. It is y of x is 3 plus 2, the integral of 1 to x t y of t dt. Okay, we need to get an initial condition. Why do we need the initial condition? Why do we need the y equals 3? Why? We need the y equals 3 because we need to get the value of c, the constant of integration. Because now we integrated everything, we got the c here, but we don't know what c is. And they said differentiate each equation and solve the resulting differential equation subject to an appropriate initial condition. Subject to an appropriate initial condition. The question becomes, what is an appropriate initial condition in this problem? So we need to think about it, of course. But I was looking at this myself and thinking, you know what? So there are many initial conditions you can give, but the easiest one is when you look at this and be like, can x be 2? Potentially, yes. Can x be 100? Yes. Why would you choose x equal to 1? So now you have 3 like this, 1 to 1. T y of t dt. When you integrate from 1 to 1, it doesn't matter what this integral is. You're integrating from one number to the same number. Then this thing is going to become 0 ultimately. And then y of 1 is going to become 3, which is an initial value. Doesn't matter what the answer is going to be here. So we don't even need to calculate this integral because it's from 1 to 1, so it's automatically 0. You know? So think about it. Think about it. Think about it. Okay, so y at 1 is 3. So we got y at 1 is 3 because we used it to get the value of c here. We solved this in Kotlin y equals x squared plus c, but what was c? We had to get c because the answer is here with the 3, but the question is what happened? So what then was done was we make y the subject. But you already have y at 1 equals 3, so wherever there's y, you put 3, and then wherever there is x, you put 1 to get the c. But what we did here, we made y the subject, and y became e to the x squared plus c. X is 1, and then y is 3. And then it means that ln 3 is equal to e to the power x plus 1. And then we're able to then get the answer. Then we're able to then get the answer. Okay. We're then able to get the answer. Any question? Think about it. Make sure you understand. Like, what would the initial value, the initial condition for this one? You can even guess the one for B now. You can even guess what you put for the value of X to get the initial value for B, because it's from 0. Here, this one you put X equal to 1 because it was from 1, so you put 1 to 1. Then you can even guess the one for B now. You know? You can even guess the one for B to say what is going to be the initial value for the problem in B. Can guess it, I'm sure. You can guess it, I'm very sure. Right. All right. Okay, think about it. What do you think about this? Okay, let me see. I'm checking the charts. Well done. Thank you so much. I was testing you. I was honestly testing you. I was testing you. So because this one in B, okay, obviously I was interested in seeing, because these are like the same kind of problems. So obviously this one you would have to integrate. You have to replace X by 0, so that you'd have 0 to 0. And then you have y of t squared divided by that squared dt. So now it means that y at 0 is equal to 1, because this one is from 0 to 0. You force the x to be 0. You just make x to be 0 so that it's from the same thing to the same thing. It doesn't matter what this integral is going to become if you integrate this. Obviously, it's very complex. It has some functions in it. It has some functions in it. So, but integrating from 0 to 0 is going to make it 0. So that y at 0 is 1. You get the point? So that y at 0 is what? Is 1. Then in the end, it means y at 0 is 1. That is the initial condition. That is the initial condition. That becomes the initial condition. We continue. So now we do everything the same way. We do everything the same way. Okay. So we continue. So now to do this, So we continue. We continue. Right, so now we do something similar for this one, and we solve the problem in a step-by-step fashion. And thank you so much for obviously trying that and trying that correctly, because I was testing you to see what you're going to think about it. So we're good. So we continue. So now you have y of x. So now let's write the problem here. This one integrate from 0 to x, y of t. So now if you find the derivative of these, you differentiate both sides. 0 to x, 1 plus t squared dt. So this is 0, and then you find the derivative of this. To find the derivative of this, you just substitute this thing here. If it's not always x, sometimes it can be 2x. Sometimes it can be the square root of x. Sometimes it can be 2x plus 3. But you take this upper limit of integration, you plug it into the place of what? Of the t for dt. Right. So now you then have y of x squared, you have 1 plus x squared, and then you have d dx of x. The derivative is then 1 of the x is 1. But sometimes it's 2x, so you must substitute in the place of the x and then in the place of the t, because it's the t, you substitute the x in the place of the t. And then you differentiate the top thing. You multiply by the derivative. I know the derivative is 1 here, but you must multiply by the derivative. Sometimes it's just 2x and the derivative is 2. Okay. So we continue. We continue. Now you need to deal with this one, and you need to be able to solve this one. How do you solve this one? Right, to solve this one, now you can just have the dy, you divide by y squared.
Sorry.
Okay, yeah?
Um, how, why, and how do you get y squared?
This y
The
squared.
dy, like this.
This y squared.
Yes, okay, yes.
Yeah, because it is y of x squared. So it's just y squared. So
Okay, so you probably
yes, because it is dy dx, so it is y as a function of x. Y is a function of x, we normally write just only y. And then you cross multiply here. If you cross multiply, then it's going to be dy over y squared, then the dx over 1 plus x squared. Right, so that now when you integrate this, minus 1 over y, and then the integral of this becomes arctan of x plus c. Arctan of x plus c. So now we just need to use the initial condition here, because we already know that this is the initial condition. Y at 0 is 1. Y is minus 1 over 1 arctan 0. Which means that you have minus 1 over y equals arctan x minus 1. So this is going to be the answer. But you just need to make y the subject out of this. So in the place of the c here, we put minus 1. In the place of the c here, because we got c equal to minus 1, so we put it here. And that is going to be minus 1 over y equals arctan x minus 1. Multiply through by the negative, getting 1 over y equals minus that plus 1, which is 1 over, now you can write it like this. It's 1 minus arctan x. So we solved this problem, and that is the answer. But this y, it's a function of x. We just wrote y here, but it's y of x. So we can write here, indeed, y of x. We can write here y of x. Right, we can write here y of x. So we solved the next question. Right, any question there? And we got the answer that they gave. This is the answer they gave. So you got that answer that the lecturer gave in the material. And then obviously we proceed to try the next question, because we don't need only do 2 questions, so we can do more. We can do more. Right, so you continue. Right, so think about it and make sure you understand everything, and then we move to the next question. The next question is very similar to this, and so we're gonna practice with it and make sure that everything is very, very clear, but also need to make sure that you understand this stuff very, very well. So move on to the next question. Okay, let us look at question 8. Obtain the general solution of the differential equation, this one. Y is less than 1/2 using separation of variables and the method of the integrating factors, Okay, the answer is the same. But first, let us use the method of the separation of variables. X squared plus 1 dy dx. So we can write this one as x squared plus 1 dy dx, and then we have 2y, we have 1 minus 2y. We have exactly 1 minus 2y. Dx. Okay? So this one you can write as 1. This is dx over x squared plus 1. It's exactly dx over x squared plus 1. So you can write it like this. At this point, we actually can be able to write this as follows. Two divided by 1 minus 2y dy. Okay. So now if you find the derivative of this is minus 2, and then this minus 2 cancels with the minus half, and then it gives 1. So you still have that back. So integrate these, which is minus 1/2. This is the ln of minus 2y. The integral of this is arctan x plus c. Okay? Okay, this one, obviously, you don't need any initial condition because it is just like this. So you just need to make y the subject. You just need to make y the subject. Multiply through by the negative 2. So you have this one here plus c, like that. Okay, so you exponentiate like that. You move the minus 1, you divide by minus 2. Which is minus 1/2 e to the minus 2 arctan x plus c plus 1/2. When you get to this point, you have this one. Plus 1/2. Okay, so yeah, let's call this one C1, 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 C1. And then you're going to call this one the half C1. So this half C1, you're going to call it Y equals C. You get this? And this C, so this is what we have. This is exactly what we have. And this is the answer they gave to us. Where is the answer? The answer is the one in green color. This is the answer. Y equals C e to the power minus 2 arctan x plus 1/2. It's the answer. But we used the method of separation of variables. So we did first part A, and then we're going to use the method of integrating factors next. We shall use next the method of integrating factors. Yeah. Let's see. Good. Where did you get 1/2? Okay, because also the 1/2 you can see it's in the answer. We got 1/2 because we got to this point here. When we're here, we divided by -2 both sides. We divided by -2 both sides. Because this -2, this -2y was there. This -2y was there. And then you had e to the that. This -2y was there. You subtract 1. Yes. Yes. When integrating first. Okay, because we integrated. We integrated first and then we got the -1/2 like this, yeah? Right. We continue. Yes, please.
I'm still confused on the half. Where did you get the half? You see, by the one, then you take 1/2 integral.
Yes.
-2. You have
Yes.
no -2 yes.
Oh, this -1/2 to say where does it come from?
Yes.
Okay, because it comes from the fact that you must first, when you have a linear expression, you must first differentiate the denominator. If the derivative of the denominator is equal to the numerator, you want it to be equal to the numerator. So what is the derivative of this denominator? The derivative of the 1 minus 2y with respect to y is going to be -2. In other words, we have the integral. of this. Okay, so, okay, good. So, yeah, when you use the formula, sometimes use the formula when you have this one here, you have f prime of x, f of x dx. So there's a function whose derivative is in the numerator, and the answer becomes the ln of the denominator plus c. Thanks for obviously being in a position to relate to this assertion here. So that at this point, what you then do is you take the derivative of this, the derivative of the denominator is minus 2. But there was no minus 2 in the beginning in the numerator. So you must put the minus 2 there. But when you put the minus 2, you must cancel it. So that, because it was not there before. But now if the derivative of this one is minus 2, how do you cancel it? You put minus 1/2. You just put it. So that when it cancels this minus, this 2 cancels this 2, you still get the 1 there. The negative is the negative, give us a plus. Right, so when you integrate this now, it's exactly of the form, this function, the derivative is in the numerator. I mean, alternatively, you'll have to let u be 1 minus 2y, blah, blah, blah. Let u be that, but it's going to be long. And then you have the minus 1/2, and you have that. Okay. And in the end, then we get this answer in green, which is y equals c e to the minus 2 arctan x plus 1/2.
Okay. So
Good.
if
Yes?
we use substitution, it's okay. We're still gonna get the same answer.
Yes, we're still going to get the same answer, even if we let u. But you see, the thing is, I did not want to use u because it's just going to be long. Let u be this, you know. So, but the answer is going to be the same anyway. Okay. The answer is going to be the same. The answer is going to be the same. Next question. Now let's use the method of the integrating factors. Okay, let's continue. So now we have the following. Okay, let's look at the method of integrating factors. The method of integrating factors is a very important method that we learn all the time. But what does this method say to us? And what do we need to do when we have this method here? This method of integrating factors deals with problems of the form dy dx plus p of x, y is q of x. Okay, so we have the following. So this is what we get. Okay, now we must write it like this. We must write it like this. So now the coefficient of the dy dx for the method of integrating factors will have to be 1. So you must divide by this x squared plus 1. So we write dy dx. Dy dx 1 over 1 plus x squared. And then you have p of x. So in other words, here you let the p of x be 2 over 1 plus x squared. And the q of x is 1 plus x squared. But it's popular to speak of the p and the q. Right, it's popular to speak of the p and the q. Right. Just continue. Right, so what do we do now? We need to find the integrating factor. The integrating factor. Okay, normally you can call it mu. Two over 1 plus x squared dx. So now the integral of the 1 plus that is arctan. Arctan x. Sometimes it's called mu. It might be called the same thing in your class, the integrating factor, but some lecturers can call it just integrating factor. Then you integrate the p of x, and if you call it I dot f dot for integrating factor, and then it's going to be 2 arctan x. When you get the integrating factor, you multiply both left and right by the integrating factor. In this case, it is 2 arctan, so you multiply the both sides there. So at this point, for example, you already have the plus 4 arctan of x. So you multiply it through by the integrating factor, which is this one. But when you multiply, then it becomes the same as d, so you can always do this. d dx of y times 2 arctan x. 2 arctan x divided by 1 plus x squared. Let us see what we're getting here. Let us see what we're getting here. Right. Yeah, it's okay like this. Let us see what we're getting. Okay, now take a look at these and reason. Take a look at these in reason. Right, we get these exactly. We got these precisely. Right, right, right. Okay, ponder on this, think about it. Make sure that you're able to understand this very, very well. So now, so we continue. We continue. Right. So, I mean, ponder on this and make sure that you have a fair understanding of what is happening here. A fair understanding of what is happening here. You have a fair understanding of what is happening here. See, the question we're asking is, will this be exactly the same as this? Will this be exactly the same as this? So you need to think about this. Will this and this be exactly the same? Because if you use the product rule, so you must always think of the factorization, and if the factorization is going to be exactly the same thing. Or alternatively, yeah, if you differentiate this, would it give that back? Because you differentiate first the y, so you're going to have the 2 arctan. So now, so it is exactly this. But if you differentiate then the y, you get dy dx, the 2 arctan. Right. And then now, if you leave the y as it is and differentiate the 2 arctan, the arctan is going to be 1 over 1 plus x squared. 2 over that. Right. And so, think about this and make sure. And make sure that you understand this very well. Make sure you understand this very, very well. Alternatively, if you have your y, obviously in the end, then you can be able to put in your y here to get the result that is wanted. To get the result that is wanted. Okay, there's something I need to change here. Just a minute. There's something I need to change here. There's something I need to change. Okay, when you got the integrating factor, there's something you need to add. Right, so it is common practice. In fact, I think, let me just write it at this point. Something I need to include here, where we then say the integrating factor, if you call it mu, it's okay, but it becomes e to the integral of p of x dx. Like this. So you have exactly this. Okay. So ideally, it's very important that you put the integrating factor, you put the integral of p of x dx on the e. And after you've done that, then you can take your, what I wanted to add, then you can take your dy dx plus 2 over this. Okay, so you multiply by the integrating factor, mu of x. Across different countries, most of the calculus books use mu. So multiply here, dy dx. You multiply this one, 2 okay, you have this. Which is divided by 1 plus x squared. Okay, you have this. Check this out. So at this point, you differentiate these, you differentiate the y, you get dy dx and the e. If you differentiate the e, it becomes the e, and then you differentiate the top, which is 2, the derivative of the arctan becomes this with the y, and the right-hand side remains the same. So what do we do now? We got d dx of y e to the power e 2 arctan Okay, and then 1 plus x squared. Now you can, well, imagine cross multiplication. Arctan x divided by 1 plus x squared. And now you take the integral on the left and on the right. Yeah, this is y e to the 2 arctan x. And what is the integral of these? Okay, so you let u be 2 arctan x. du is 2 divided by 1 plus x squared dx. Here we have the integral of e to the u, 1 plus x squared, the dx. Du. E to the u du. Plus c. The u after that. Right, let's check what we're getting here. So at this point, you divide by the e. So you divide by e. So c okay, now this one is gonna let's see. Yes. Let's see what you're gonna have here. Is this not just e? Okay, this one is e to the u. But u is arctan, so it's e to the 2 arctan x. So we divide which is ce to the minus 2 arctan x plus 1/2 plus 1/2. Which is exactly the answer here. Okay, what's the method of integrating factors? What the integrating factor is? The integrating factor formula is this one here. So it is mu of x, which equals e to the power, the integral of p of x dx. Let's move on to the next question. Well, the answer is the same. I must indicate that before we move on. The answer is the red one up here. It's exactly the same as the one we got before. We used before separation of variables, and we got the minus 1/2. We could have used u here, let u be 1 minus 2y. Yeah, it's the same thing, but we got the same answer. The answer became the green one, the one covered in green. And then you have this. Okay, yeah. Okay, good. I'm excited that we're moving to part 6 now. Thank you. This is part 6. Right, part 6 is a very interesting one. Let us get started with part 6. Now, here is the problem in part 6. Here is a little problem in part 6, and we're excited. Right, but first things first, this is method of integrating factors and method of integrating factors. So the method of integrating factors tells us something that dy dx p of x y is q of x. So you must write it like that. Dy dx plus y is 1 over 1 plus e to the x. Right. Continue. What is our p? Because you compare it like this. Okay, look. So now, okay, we have our p, meaning the integrating factor. What is the integrating factor? The integrating factor is mu of x, which is e to the integral of p of x. So that mu of x is e. What is p? It's 1 dx, which is e to the power x. So the integrating factor is e to the power x. You multiply both sides with it. So when you have dy dx, which is e to the power x, which means it is d dx, which is e to the power x. Okay, we have dx. And then we have e, which is e to the power x divided by 1 plus e to the power x dx. And then what is the integral of this? Which is e to the power xy, which equals the ln. Now, this is what you have. So now this is the answer, but we need to just deal with the C. One plus e to the x plus c. Which is e to the power 0, which is the ln of 1 plus e to the power 0 plus c. X is 0. Y is 3. 3 is the ln of 2. Okay, which is e to the power x. C, which is, yeah, so I mean, you come to this point. This one is C, so you put plus C. Put plus C there. But the C is this. Here, this equation has a C in it, and then you plug in the C, which is the ln of 1 plus e to the power x. The C is, what is C? 3 minus ln 2, which is exactly the 3 minus ln 2 we're seeing here. So you solve for y, and therefore this e to the power x, you divide by it. So it's going to be e to the minus x. Then there's 3 minus ln 2. So that becomes the answer. Any question? Okay, so that is the first problem, but obviously first problem, we started here of using integrating factors. First, we need to write it in standard form, and the standard form is dy dx plus p of x, y, etc., etc. Right. So we continue. We continue. Right, we continue. So now we move on to the next one. I think that we're going to give this one as an activity, then we shall come back to it. So this one is a little activity that you can do during your own leisure. We shall return to it in the evening time. Okay, I'm expecting that we must be able to do 11. Because there's someone now who brought the, I wanted us to do 3 slots today, but we've done 2. And so there's another discussion at 6. But I wanted us, yeah, but I think that gives you 6 as a break. Okay, that's okay. It's a break for you. Then we can come back at 11. Right, so this one is a little problem that you can try, but obviously we're going to do it. We can do it, but now we can practice with it quickly, and then we have everything we need. So cosine x dy dx. So x is 1. You must write it in standard form. What is the standard form? Dy dx pxy equals q of x. So you must make sure the coefficient of dy dx is a 1. Divide by the cos. So it becomes sine x over cosine x. You divide 1 by cosine, it becomes a secant of x. Obviously, I mean, you can come and then say, but this is dy dx plus the tangent of xy is the secant of x. What is our p? Is the tangent of x. Dx. Okay, what is the integral of the tan? The tangent is sine over cosine. The derivative of the cosine is minus sine. So this is going to be minus the ln of the cosecant of x. Minus the ln of the cosecant of x. Or you could also say it is the ln of the secant. Okay, let's write in a nested manner. Minus the ln, which is e to the ln of the secant of x, because 1 over cosine is a secant. So we continue. So now what then are we able to achieve out of this? So we continue. What then are we able to get out of this? Okay, this becomes integrating factor. It relates to the secant on the right. So, okay, so we're going to multiply both sides by this. So, dy dx which is like x e to the ln. Okay, we can simplify it. We can simplify it because what is e to the ln of secant of x? This is just the secant of x. So we can use that. Multiply both sides by the secant here. Dy dx. Okay, so this is 1 over cosine. Sine over cosine. Yeah, it's okay. So d dx of the secant y. Which is the secant y. You have the integral of this. It's like xy, which equals 10x. plus C. So that is the answer we're getting. So if we're getting this answer, you can use this point. Sec xy is 10x plus C. Okay, what is 10x plus C? Use this one. Okay, x is an element of this interval. Subject to this, yeah? So x is pi over 4, y is the square root of 2. Which is the square root of 2, which is the tangent of pi over 4. And this one is the square root of 2, then the square root of 2. The second is 1 over cosine 45, no? Which is the square root of 2. All right, so the 10 of this becomes 1. C becomes square root of 2, that 2 minus 1. So you have this. So now you can divide 10x, you divide by the sec 1 over sec x. Sine over cosine, this is sine. The secant is 1 over cosine, so this is cosine x, which is exactly this answer. So now, that is what we have done here when we solved this particular problem. When we solved that particular problem there. I think that we're going to take a break and then we shall return again at 11. Okay, I must be able to send the recording in due course. But thank you for joining us. It was awesome having this discussion. We shall send the recording before that. But for now, take care and goodbye. I can give you just one little problem. C is the problem. Let's see. Yeah. So you can try C. They're saying the answer is this, but use the method of integrating factors. So that is sort of the literary activity. Obviously, it's not good to give so many problems for you to do. Just try the C, and then when you return at 11, we shall do a lot of the other remaining problems. Right. Thank you so much for joining us. You try the 1C in part 6. Thank you, and take care. Until 11, we shall send the recording, but goodbye. Right. Goodbye.